Bismillahirrahmanirrahim. Assalamu alaikum. In the last session, we calculated volume of a cylinder. So let's continue with that cylinder. And now we have to calculate surface area of a closed cylinder. Okay, right. Last time I showed you a cylinder like this, and we were considering this cylinder, and I said that this part is the height of the cylinder, and then we said, okay, the cylinder has a front and the back, and both the front and the back both are circular, right? And we were calculating the volume of a cylinder. Now, since we have to consider surface area of a cylinder now, so let's assume, so this is the model for a cylinder. We are going to assume for calculating the surface area. Now this, you see, I said that we are going to calculate surface area of a closed cylinder. See, this is closed cylinder. Okay. So this part is the height of the cylinder. Front of the cylinder, circular. Back of the cylinder, circular. Right? Okay. Now, if we look at the net of the cylinder, so this is the front. I have this thing, circle over here. This is the back. Okay, I have a circle over here. So it means that when we are talking about surface area of a cylinder, we're going to deal with two circles, one at the front and one at the back, right? And it's a closed one. So that is why we are going to take a surface area of this front, surface area of this back, right? Both are circular. Keeping in mind both are circular. Okay. And for the circular area, what do we do? Pi r square, of course. And we have this pi r square and we have this pi r square. So it will be 2 into pi r square. So when we will come to the formula, we'll be dealing with two circular areas right now. Okay. So now we have considered the circular part. Now this height of the cylinder. So what should be the surface area of this part? Okay, if I suppose I remove this front now, you see this is circular, right? And how do you calculate the circumference of a circle? For calculating the circumference of a circle, what do we do? 2 pi r, right? So if we know the radius, we multiply with 2 and pi and we get the circumference. So it is circular. So it is circumference of the circle, right? This thing is the height of the cylinder, right? Keep in mind, this is the height, okay? This is circular part. And for the circular thing, we take 2 pi r, right? Keep in mind, circular part, height. The height is the h. Height, suppose height of the cylinder is h, and the circular part, for the circular part, to take the circumference, we take 2 pi r, right? Now, if we agree with this 2 pi r and h, I'm going to unfold this cylinder, right? What was this thing? 2 pi r. What was this thing? Height. So it's a rectangle. And what are we going to do? 2 pi r into h. So this thing is rectangle now. And now what are we going to do? This from here to here is our 2 pi r. This thing is our height, h. And for this, we have radius. And for this, we have radius. And we are going to have area of this 2 pi r h, and for the area of this and this, pi r square, pi r square. Okay. Now let's move to the formula. So surface area of a closed cylinder is equal to how many base areas? 1, 2. So 2 into base area plus area of the curved part. This was our curved part. So what are we going to have here? 2 pi r square, right? Pi r square. So 2 into base area, we have 2 pi r square plus 2 pi r into h. 2 pi r into h. So this is our formula for the surface area of a closed cylinder, right? Now let's apply the values. Suppose I have the values over here. The height is 12 centimeters and the radius is 5 centimeters. So it will be 2 into 22 by 7 into 25 plus 2 into 22 by 7 into 5 into 12. Okay? And if we calculate this, this is going to be 534, approximately 534.3 centimeter square. So this was about the surface area of a closed cylinder. Hope you got the idea. Let's do one more example of a cylinder, and then I'm going to conclude this chapter. Okay. Okay, now we have a metal pipe, right? The length of the metal pipe given is 35 centimeters. Okay. Now it's a pipe. Outer diameter is 28 millimeters. Inner diameter is 20 millimeters. And we have to find the volume of the metal used in this pipe. So this part is basically, this is the thickness of the pipe, right? It is open. This is the thickness, and the thickness of the pipe and the length of the pipe has taken some metal, and we have to find the volume of that metal. Okay, now for that matter, what are we going to do? We are going to calculate the volume with the outer diameter. We are going to calculate volume with the inner diameter, and then what are we going to do? We are going to subtract from the outer volume the inner volume, and we'll get the volume of the metal used in this pipe, right? Pretty easy. So first thing, if the diameter, this is inner diameter is 20 mm, which is, so the radius is 10 mm, and which is 1 centimeter, right? Now the outer diameter is 28 millimeters. So radius is 14 millimeters, and it is 1.4 centimeters. Now why I am taking in centimeters? The reason is this is given in centimeters. Either I have to convert this to millimeters or this, the millimeters to centimeters. One and the same thing. Either you can calculate in millimeters or you could calculate in centimeters. Now coming to the centimeter has a reason. You see, I have 1 centimeter over here, so calculation will be easy, right? So let's take that. So now the inner volume, so how we calculated the volume? Circular and the height, pi r square h. So it is 22 over 7 into the radius. So we are talking about inner, the inner radius is 1 centimeter. So 1 square into height, which is 35. So 1 Ones are, fives are, so it is 110 centimeter cube. Okay, so we have the inner volume now. Outer volume. Equals pi r square h, which is 22/7 into 1.4 square into 35. Fives are, so it is equal to So it is equal to 215.6 centimeter cube. Now, the volume of the metal used. Outer volume minus inner volume which is equal to 215.6 minus 110, which is equal to 105.6 centimeter cube. Okay, so this is our answer to the question that the volume of the metal used for this much pipe is 105.6 centimeter cube. So I hope you got the idea of how to calculate the surface area and the volume of our 3D figures and the 3D things. So we have done cuboid, cube, triangular prism and a cylinder, right? So we'll do the we'll come back to this topic when we are discussing D2 chapters, right? For now I am concluding this chapter, so I hope you have understood. Give me your feedback. Thank you very much.